Hello everyone, welcome to my channel. My name is Lloyd. If you are new here, kindly subscribe to the channel. In today's video, I'm gonna talk about how Git and GitHub works. Have you ever wondered how developers collaborate on code without necessarily breaking things? So in this video, I am going to break down how Git and GitHub works, from version control basics to how teams manage, track, and deploy code efficiently. So if you are new here, kindly subscribe to the channel. And also, if you are a beginner or someone transitioning into software development or DevOps, this video will give you a solid foundation to start using Git and GitHub with confidence. Let's get started. So the prerequisite for this video, you need to have Git installed on your laptop. You also need to have a GitHub account created and a basic knowledge of command line interface. So what is Git? Okay, Git is a free and open source distributed version control system designed to manage and track changes in source code during software development. So Git allows multiple developers to collaborate on the same project without overwriting each other's work. And it makes it easy to revert to earlier versions if needed. Let's look at some of the benefits of version control systems. The first one is traceability. So Git records every modification, and in modification you need to consider the following, like who made a modification, what was modified, when was it modified, and why. So this makes it easy to understand project evolution and also debug issues. And then you also talk about what? Collaboration. So collaboration, in terms of collaboration, Git allows multiple people to work on the same project simultaneously, merging their contributions seamlessly. And that's what collaboration is about. And then we also have backup and recovery. So Git serves as a robust backup. If, assuming you are working on a project and then you push a code to either a staging or a production environment and then something breaks, you need to revert back to the previous stable version. So in this instance, we call it what? Rollback. So Git allows you to be able to roll back to your previously changed code. We also have branching and merging. So Git enables isolated development of new features or bug fixes without affecting the main branch. And basically, you can integrate them later. Code quality and review. So Git facilitates code reviews before changes are made. And so you are able to catch bugs and improve overall code quality. And efficiency and speed. Git speeds up development cycles by automating workflows. That's reducing conflicts and allowing faster collaboration and more confident deployment. Then we also have consistency. So Git eliminates confusion over outdated files, ensuring that everyone works with the correct approved. So in terms of consistency, in case you have like two or more developers working on the same project, and then one of them made changes 2 days ago. Now, the two other developers working on this project, if one also wants to commit their code to the same repository or make changes to the same project, they need to pull the changes that the previous engineer made before they can be able to push their changes as well. And so that's what consistency is about. Let's look at basic Git terminology. as a DevOps engineer or as a software engineer, you need to understand these terminologies and how they work. So you talk about a repository. So a repository is a storage space or directory where your project files and their entire revision history are what stored. A local repository. So the local repository is a copy of a repository that's stored on your personal computer. We have a remote repository as well. Now, a typical example could be GitLab, GitHub, or Bitbucket. So, a remote repository is a version of the repository hosted on a server, and this also enables software engineers to collaborate seamlessly and then also back up their projects on these servers. And then we have directory. So the directory on your local machine where you actively edit files. So you can consider this to be like your VS Code environment within your project directory. And then we also have the staging area, a temporary area where you prepare changes to be included in the next commit. And then we also have commits. So a commit is a snapshot of your project that's specific that at a specific point each commit has a unique identifier which we call what hash, and includes a message describing the changes that were made. Now let's look at branch. So a branch is an independent line of development. Branches allow you to work on new features or bug fixes in isolation from the main code base. So they are essentially movable pointers to commit. And then we also have, yes, so a typical example of a branch could be like a dev branch, staging branch, production branch, or even like bug fixes branches like bug fix branch or a hot fix branch. And then we have main and then master. So these are like default branch names in a repository, typically used for stable production ready. But I think now there's been a shift in terms of how branches are being named. So we have like the testing environment, which mostly people call it testing, and then we have staging environment, and then the production environment. So repositories are created for default repository names are being updated to suit the type of environment. So you can have like a dev environment, so you can have like a dev repository. And then we also have a head. A head is a pointer that indicates the most recent commits on the currently active branch. Clone. The process of creating a local copy of an entire remote repository. And then we also have fetch. So fetch allows you to basically download changes, comments, and then also branches from a remote repository to your local repository without integrating them into your working files. This lets you review changes first before you commit them. And so that's how fetch works. And then we also have pull. So pull, in terms of pull, we are able to pull changes that has been made to codes that we are working on or a project that we are working on, so that our local repository could have like the updated files or the updated changes that were made by another developer. So a pull is an automated command that runs git fetch to download changes and then immediately runs git merge to integrate those changes into your current branch. We also have push. So push is the process of uploading your local commit. So in your local repository, you push the changes that you made the remote the remote repository, and those changes are stored on the remote repository. Well, we have merge. So merge is the process of integrating changes from one branch into another. Conflict, a situation that occurs when Git cannot automatically make changes because two or more changes modify the same line of files. Fork, a copy of a repository hosted on a remote server that allows developer to experiment without affecting the original projects. These are basic terminologies that you just need to understand what they are. We also have git ignore. So a git ignore is a text file that tells Git which files or directories to ignore when tracking project files. And you can essentially store environment variables or even logs in this particular git ignore file. We have commit often. So with commit often, it is very important that when you are writing a code, okay, you you don't push, you don't wait till you write all the code before you push it. You need to ensure that you commit the code frequently, and then once you are committing the code, you describe what changes were made, or if there are new updates, you ensure that the message that you are committing reflect the changes that were made. And so that is why it is very important. Okay. Use branches. So always ensure that you don't use or make changes on the main project branch. It is very important that you always check out from the project branch to create a sub branch, and a sub branch could be a hotfix or even a bug fix branch. So after fixing the bug or whatever it is that you are changing, you just commit the changes to the main branch, and so this way nothing affects the main branch. The main branch remains stable. Also ensure that you write clear messages. Use descriptive messages that explains what and why the changes were made. Regularly pull changes. So it is key that you don't always write, just open your laptop to write code, but make sure that once you open your VS Code and you are working in a team project, you always make a pull. So you have to pull changes that were committed by previous developers so that you can have like a complete or those changes on your local branch. This helps to avoid what merge conflicts. And then also regularly review code before you merge them. Ensure that you pull requests or code reviews to ensure that what the code is quality and you can be able to catch issues early before they escalate. And then finally, back up your work. Make sure that you push your changes to a remote repository. In an instance where your laptop gets stolen or missing, you probably have those projects in a remote setting, and then you can always access it. Yeah, resolve conflict promptly. So address merge conflict as soon as they arise to maintain a smooth workflow. Use git ignore to exclude unnecessary files from being tracked to keep the repository clean. Examples, I mentioned these examples earlier. You can have like a log files, a very large log file, even node modules. Um, you also have like build artifact and sensitive information like database password and all of that. So you don't need to commit all these into the repository, and then document your work. It is important. So maintain documentation on branching strategies that you are using. So if your branching strategy is from testing to staging to production, you make sure that all the developers know the branching strategy that you are using so that they don't mix up their code into branches that they don't need to push testing codes there. Alright, so we've looked at GitHub. We've looked at Git. Now let's look at GitHub. So GitHub is a web-based platform that hosts Git repositories in the cloud. It makes it easy for developers to share, collaborate, and contribute to projects. GitHub also provide essential features like pull requests, code reviews, and project management tools. Now let's look at some key features of GitHub. So these are some of the key features of GitHub. You can talk about remote repositories. I spoke about remote repositories earlier. So you can store your Git repositories in GitHub, and then also make ensure that every change that you make, or every push or every commit that you make, is accessible by other developers that you are working on the project with. And then we also have pull requests, so a way to propose changes. So pull requests are basically a way to propose changes to the repository, and others can review these changes that you are proposing, discuss when it is needed, further clarification, and then once those changes are approved, you can merge it to either a production or a staging environment. And then we also have forking. I mentioned forking earlier. You make a personal copy of someone else's repository so you can modify it without affecting the original project. And then finally, GitHub Actions. GitHub Actions automate tasks such as testing or deployment when changes are pushed to a repository. Now let's look at the Git workflow. Okay, so a traditional Git workflow has like three stages. Okay, the first one is the working directory. So that's where you are actually working or writing an active code in that working directory, and that's probably on your machine. And then we have the staging area. So the staging area is where changes that you have made to a particular code, you just commit them to your local repository. So once you commit them to your local repository, they stays in that stage until you make a commit or you push. And so that's the staging area. And then finally we have the Git directory. So the Git directory is where commit and version histories are what saved. So if you want to refer back to a previous version, you need to do that via the Git directory. Now let's look at the Git workflow diagram. So this is the Git workflow diagram. You can see we have to develop US here. Um, this developer here has its own local repository. This developer also has its own local repository, which is this. Now this developer will write the code and then add the code to the local repository. Once testing is done and the code is approved, this developer will push the code to the remote repository. Now, when the first developer push the code to the remote repository, before the second developer could work on the same project, they need to do what we call pull. So they need to pull the changes that has been committed by this developer to their local repository. So as you can see, we have the arrow. That's pointing to both the local repository and then the remote repository. So this developer will make a pull request. So it will pull the changes that has been committed by this developer onto the remote server. And then once that is done, then they can begin to make their changes. Once they make their changes, they will also add their changes to the local repository. That's by committing them. And in this instance, they are being staged. Okay. So once they make a push, then that push, those changes made from the code is pushed to the remote repository. And the use case for clone is when so assuming here we are adding a third developer. Okay, this third developer doesn't have access to whatever is happening here. Now we need to add the third developer to the repository, and you do that by using their email. So they receive a notification that they've been added to a repository. Now the next thing they need to do is to clone the repository. So you are going to make a copy of the remote repository and then pull that onto their their local repository. So that's why we use um cloning. So we clone the remote repository onto the third developer's remote um laptop, which is the local repository. And then once they also make their changes, the cycle continues. So this is how the Git workflow looks like. Now let's look at GitHub. Okay, let's look at GitHub. So when you go to Google, you just type GitHub. Now GitHub, I mentioned earlier, is a web-based application that allow you to essentially store your code in an environment. So as you can see, this is my GitHub repository. As you can see, this is my GitHub account, and this is all the repositories that I have here. When you go to my profile, so this is my GitHub profile. This is my GitHub profile. And these are where all the repositories that I've created lies. So you need to also create your GitHub account and then push all the codes or all the project that you are working on. Okay. So I created this project called GitHub, and this is our project directory. When I go to the terminal right now, you see that it will essentially open my project directory, and when I do list, there is nothing that is in this project directory. Now what we are going to do is that we are going to do a demo and then also learn about some Git commands. Okay, so essentially I'm going to create a file in this working directory, and then I'll name it test dot sh. Okay, so this is a shell script. Okay, and we are going to do something, and then we push it to the Git repository. Okay, okay, so we are not going to do anything massive. We are just going to do a few scripts, and then we'll commit. So we are going to commit this to a repository. And before we do that, you need to make sure that your repository is connected to your local machine. Okay, now how do we go about that? You go about setting up your email address and then also your password. Okay, so I'm going to show you something real quick. Okay, if I want to add my GitHub credentials to my local machine, okay, in the terminal, the first thing I need to do is to do git config. So what I'm doing right now is that I'm adding my username, my GitHub username, and then email, so that from my local machine I can be able to push the changes. So this particular code right now is on stage, is on track, because we have not initialized Git in this regard. Okay, so git config, I want to do it global so that it doesn't only apply to this repository. You can do it to apply to just this repository, but I want to do it global, which I've already done. Okay, I've already done it. So this is just for demo purpose. So for global, you need to bring the flag, the global flag. So global, and then you input user dot name, and so this will be the name of the user. And what is the name of the user? We can do a user Lloyd. Okay, a user Lloyd. Now, also ensure that you are using your username, your GitHub username, and not just any random name. So my GitHub username is Lloyd Theophilus. Okay, so that's my GitHub username. Now if I hit enter right now, it will add it. Okay, I've already done this. I don't want to mess things up, but this is just for them. But I just want to show you exactly what. So once I hit enter, it will save this configuration, and then the same thing applies to, so in terms of adding the email, you can do user dot what email, and so I need to type my email here. So you type your email at example.com. So now what is happening here? I'm adding my email. So GitHub will be able to identify me as a user to be able to allow me to push my code changes to the repository or the project that we are working on. Okay. So that's how you configure GitHub to allow you to push code from your local machine to the GitHub remote server. Now you need to check the version of, if you already install GitHub, okay, if you already install Git, okay, and also if you don't know how to install Git, you can essentially go to this website. You can go to this website and then install Git based on your operating system. So you have Windows, Mac OS, Linux, and maybe what that means is it built from what source. So I think the most important ones are the Windows, Mac, and then what Linux. So you can go to this website, just Google Git, and then you go to the main website and then be able to install Git on your own. So let's come back to VS Code. Okay, so you need to check the versions. Let me check the version of Git that I have, dash version. And as you can see, this is the current Git version. That's what I have. Okay, so this is big enough. Great. Okay, so this is the current Git version that I have, and I think it's fine. I can still use it. So after setting up your username and then your email, now you can be able to communicate to GitHub from your personal laptop. Okay. Yeah, like I said, you need to create an account on GitHub. And you need to create an account on GitHub. And so that's how you set up down. Now before we push this particular code to our repository, we first of all need to initialize this. Okay, so how do you initialize our local repository? You do get init, and this will initialize our, so as you can see, as soon as I did it, says initialize empty Git repository. So now Git has Git has been initialized in my project. So as you can see, this is the message we are when we did Git in it. So that's how you initialize Git in your project. Okay. So now my project is being tracked, but I haven't made any commit yet. So now that my project is being tracked, okay, I don't have any repository created for this project. So how do I go about that? I need to create a repository. Okay. As of now, when you check down here, it says that I'm in the master branch. I'm in the master branch, but I haven't created any repository yet. But Git is assuming that I'm working in the master branch. So I need to create a repository, and this repository will allow me to be able to commit my code, this particular code here to the GitHub remote server. Okay. So how do we go about that? We go to the GitHub repository. We go to the GitHub repository. Now in the GitHub repository, we create a new repository. So let's click on new, and then we'll name our repository as test dash what. Let's name it as demo. Okay, so it says demo is available. Now let's look at our remote. Our repository is a public repository. If you are working in an organization, you need to change this to private. Okay, but we are working in a public organization, so sorry. We are working. This is a demo for demo purpose, so it's fine if you leave it as public. But if you are working in an organization where you need to protect the company's properties, especially the code base, so you need to change that to private. Okay, so you can just go. You can leave the rest as default. Gating, no, we don't really need gating, no. Yeah, I say in the course of the code we can set it up, and then but right now we don't have any sensitive file to hide, so we don't really need. So we create a repository. So now that our repository is created, what we are going to do is that we are going to we've done this already. We've initialized the repository. Add a readme. We don't need a readme. We'll comment the code block, and then also ensure that we are which branch we are using, the main branch. So let's start. So we've already initialized the repository. The next is to commit our changes. So now we do get commits, and we need to the M flag you are seeing here is not just for fun. Okay, this is for message. Let me increase this. So this means message, and what we are message, because we are committing these changes for the first time. We do initial commit, and then hit enter. So let's see what happened here. Git says that on your master branch initial comments on track files. This particular file is not being tracked. So nothing added to the commits, but on track. But on track files are present. So it means that even though we initialize the Git repository, Git is not tracking this particular file because we haven't added it yet. So first of all, what we need to do is to do Git add, and we are adding. So this particular dot here simplifies that we are adding all the files here. Now you can also instead of using this dot, you can specify the file that you want to commit. Okay, so in the meantime, because it is our first commit, we'll commit this particular what file. So let's do that. Okay, so now the file has been what added successfully. Let's go back again to our commit, initial commit, and then let's do what commit. So now you see that after we added the file, the status has changed from green to what to white. So it means that now what Git is what tracking our file. Okay, now let's do what we call Git what status. Okay, so now that the file is being tracked, when we hit Git what status, say on branch master, nothing to what to commit. Working tree is what clean. So it means that what there are no new what files that are being what that are being staged. Okay, there are no new files that are being what added, and so just the file that we what added. Okay, now GitHub says that what we need to what specify the branch, and here we can see we are working in the master branch, so we need to specify the what the branch. And how do we go about that? You run this what command, so that's git branch. So you specify the what the branch. So the branch is what main, eh? Because when we initialize or we created a repository, the branch that was created for us is what main. So we need to what ensure that we are using what main. Now let's hit what enter. So what had just happened is that our working directory has now been added to what this what particular branch, which is the main what branch. The next thing we need to do is to ensure that we set up the remote what URL. So because this is a remote server, we need to ensure that what we set the remote URL. This is a long command, so let me just copy and then I'll what paste. So what we are doing here is that what we are adding the origin. The origin is the what the repository what URL. Okay, we are adding the origin, which is what the repository URL. And so we are telling Git that what every time we add a new file and then we commit it, we want it to go to, in this particular working directory, we want it to go to what this particular what repository, and it has to go through what this URL. Okay, so now let's hit enter. Okay, so now our URL has been what added. Our URL has been what added. So this is more like a tunnel that what we go through to access what our repository on the remote server. Okay, now that our URL has been added, let's look at what we need to do next. Next is to what push our changes. So we need to push our changes. And how do we push our changes? We need to what run this command. So git what push. And then we want to specify the upstream. Okay, we want to, so if you check here, we have what this particular upstream flag. So we need to specify our what upstream, and the upstream flag. So now that you have your upstream flag, the next is to specify the origin, and the origin is what main. So main is the what the branch name. So let's see what happens. So as soon as we push, as soon as we made that what push, our files has been what pushed to the repository. So it says what counting objects. It counted the number of objects, and in the object is what 3. So you can see it stated what 3. That's the 3 objects, and then it compressed the file, write the file. Or these are just gates. So when we were going through the slides, I mentioned head. Okay, and so as you can see, this is our what head. This is our what our head, And so the new branch that we set, which is what? The main. Okay. And this is the repository, so you can see two. So the files were pushed through Git to what? This particular URL to what? The remote what? Server. Okay, to the remote server. And so now let's go back to GitHub and then reload this page. Okay. As soon as we reload this page, you see that we have what? A branch that has been created, which is what? Main. Okay, a new branch has been created as what? Main. And then inside the branch, we have this particular file, and this is the file that we created. So this file has been created and then pushed to our remote server. Now when you open this particular file, you can see the object that we have in that particular file, which is what? The three objects that we have. And when you go back, we have the commit message. We spoke about commit message. So because this is our first comment, we just do what? Initial comment. But in our subsequent commit, we need to ensure that what? They reflect the changes that what we have made. Those commits reflect the changes that we have made, so that when somebody looks at our repository, they know that what? Okay, on this day, these changes were made, and you can see 6 minutes ago we made these changes. Okay, now let's add another file. We're going to add another file, or even create a folder and name the folder and name the folder. How do we name this folder? Okay, let's do UI. Let's name this folder UI. Okay, and inside this folder we are going to create a file, and let's say front end frontend.ts. Okay, so let's say this is like the TypeScript file. Okay, we are not going to write anything in it. We just create another file and say backend.ts. Okay, so this is also a TypeScript file. Now, as soon as we created these files, we created a folder, you see that the color has changed. Okay, now what is happening here is that what? This file has been what? Emphasized for us by Git, that I know you've added new files and currently they are not being what? Tracked. Okay, so let's clear the screen and then type git status. Now as soon as we did what? Git status, it shows us what? Our branch history. So it says what? On branch main, your branch is up to date with what? Origin main. Now, even though your branch is up to date, you have what? On track files. And what is that file? This is the file. So it says, well, use git add file, the name of the file, to include in what will be what? Committed. So this is the file that we created. Now this file is a directory. So you can see we have the directory, that's the forward slash. And inside this particular file, inside this particular folder, there are what? Two files. So there's nothing to add comment, but on track files present, use git add to what? Track them. So now let's track these files. As soon as we do git add, you see that the status will change from green to what? To white. So it means that this particular file is now being tracked by what? Git. So let's do that. Git add. So now our file is being what? Tracked. Okay, our file is being tracked. So let's do git status again. Okay, so you see that as soon as we did git status after adding the git add, okay, so your branch is up to date with the origin main, changes to be committed. So now git is what? Tracking our file, and it is telling us that what? These changes has not been what? Committed, and we need to use git reset head file, the name of the file, to what? On stage. So what is happening here is that now these files are being tracked and they are what stage ready to be what pushed to the remote server. So once we commit this file and push it, it will what be added to the remote server using the URL that we stated earlier. Okay, so let's do this. Get commit, bring the message flag. So what did we just do? The message is what? Created UI folder. And that's what we did. We created a UI folder, we didn't add anything, it's just two files in it without content. So we just do what? Let's see what happened here. It says git commit. Oh, I made a mistake, spelling mistake. So let's rectify that and then hit enter again. Okay, so you can see as soon as I made a correction and then hit enter, it says what main. So this is the hash. Okay, this is the hash I spoke to you about. Created UI folder. Say two files changed. And what are those two files? These ones. Okay, zero insertions. Zero insertions means that there is nothing in it. And then there are also what? Zero what? Deletion. So it says what created mode and then it specified the hash and then also for the second one, so both the back end and then what the front end. So now these files are being what staged and they are ready to be what push. So as soon as we do get what push origin main, these files will be pushed to our remote repository using the URL that we specify when we're adding the. Because so as you can see, the the files has been what added. Let's go back to GitHub and then refresh the page. So as soon as we refresh the page, you see that our folder is what shown here. When you open it, we have what we the files that we created, backend.ts and then the front end. So that's how you interact with what Git and then what GitHub. Okay. All right. So the next thing that we'll do is we need to look at what branching. Okay. Now, as it stands now, we only have one branch. Okay, which is the main branch. When you go to view all branches, we just see what one branch. Now we want to add another branch. Okay. So let's say this is our main deployment branch. We want to add another branch. Okay. How do we go about it? So we do what get what branch and then the name of the branch that we want to what create. Okay, so let's do something like a what a feature. Okay, so this is a feature branch. Then we hit enter. Now the branch has been what created. Let's go back to the browser and then refresh this and then need to refresh this. um let's see. Okay, so this branch is now created. Let's check out. So we need to switch into what that branch. And how do we go out? You use what get what checkout. And then the name of the branch is what feature. So enter. And now if you check below here on the taskbar, you can see that what we've now switched from main to what feature. Okay, now let's do ls. So you can see we just have these files that are in the main branch. The same files are here, so I can make any modification and then commit it. So let's make a modification. Okay, we can have something like, let's just write a comment. my first branch file, and then also add a comment here, my first TypeScript file. Okay, now that we've added this, so we are working from this branch. Okay, we are no longer working from the main branch. So every change that we do here does not affect the main branch until we push these changes or commit these changes to the main branch. Okay, so let's do this quickly. Okay, I want us to see something real quick. Now let's commit these changes to the main branch. So we do git what add. Get commit. We bring the message flag, and then what? Bring the message. So what do we do? What will be our message here? So what did we do? We just added comments in the two files that we created. So we can say added TypeScript comment in backend dot ts and frontend dot ts. So now let's comment this. So as you can see, now these files has been what? Staged. Okay, now let's push to the remote repository, git push origin. What's our origin? That is what? Main. Then hit enter. So these files now will be what? Pushed to the, oh, so yes, I made a mistake. I was supposed to push to the feature branch. Instead, I made a mistake and I typed what? Main. So as you can see, because this particular change that we made is not affecting the main branch, it is what? On the main branch, everything seems what? Fine. Everything is fine. So let's change this to feature. Okay. And then enter. So as soon as we change the branch origin to feature, because these changes are being made on the feature branch, you see that they've been quickly what? Pushed to the feature branch. Okay, now let's go back to the GitHub page. So now you see that our branch is now what? Available. And then let's go to the code and then switch the branch to feature branch. So as soon as we have two branches now, GitHub is telling us that what? Feature has had what? Pushes, that's 31 seconds ago. So we should compare and then create a pull request. So this pull request that we'll create will be pushed towards main. Okay, so, but I just want us to check. So as you can see, this is the message or the comment message that I wrote earlier. And then so I've switched the branch to what? The feature branch. And inside the feature branch, we have what? We have the files that we made changes to. So let's open one of them, which is the backend. So you can see the changes that we made to the file. And then when you go back to front end, we have that change that we made as well. Okay, so this changes that we made is only in the feature branch and not in the main branch. Now let's switch to the main branch. Now when you go to main branch, okay, let's open the backend. So as you can see, as soon as we open it, it is what? Empty. Because those changes has not been what? Pushed to the main branch yet. And the same thing happens to the front end. It is what? Empty. Now let's go back to the CLI, okay, and then clear the screen. So now we want to commit these changes to the main branch. So let's check out of this branch into the main branch. So git checkout main. So now we have switched to the main what branch. We have switched to the main branch. The next thing that we need to do is to merge the changes in the feature branch into the main branch. So let's do this. Git merge. Which branch are we looking at? We are looking at what? The feature branch. Hit enter. So you see it is now updating the what? The hash. Okay, it is now updating the hash, and it says what? Fast forward. We are committing these files to what? This particular branch, which is what? Main branch. Okay, now let's do git push origin main. Hit enter. Let's see what we have here. It says what? Git push is not a git command. Yes, so spelling mistake. So let's rectify that. Yeah, sometimes these things happens when the hand is faster than the brain. And then hit enter. So now all the changes that we made on the feature branch has now been what? Committed into the what? The main branch. Let's go back to the GitHub repository and then what? Reload the page. So as soon as I reload the page, we are already in the front end of TS. So you can see the changes has been what? Committed here. And then the same thing for the what? The back end. We are still in the main branch. So now the feature branch and then the main branch has what? The same what? Code changes. Okay. I can make a change in the feature branch and not commit it into the main branch, but rather stage that particular changes until every possible test is done that I can push. Now let's create there's a way to also create another branch and just check out without running two commands. Okay, and that includes git what? Checkout. Then we bring this flag. So this flag means what? Branch. That's the what? New branch, as you can see. New branch. So we are creating a new branch and we are checking out of that branch. So let's check out. The branch name will be let's do hotfix. Okay. And then enter. So we created a branch and then we also check out of the branch. So the branch name is hotfix. So as you can see, we are now in the hotfix branch. Okay, let's add changes. Okay, we made a mistake. We made a mistake in the feature branch, and then we committed it into the main branch, which is our production branch. Now we want to rectify that change. So hotfix. Let's use this. This file is part of the front-end UI models, but it is currently empty. So we just updated this. Let's update the backend too as well. Fix the backend UI model issue. So we added two hotfix issues. Now let's commit them. Git add. So let's add the, so now this file is being tracked. Let's do commit. Let's commit it. A message fix the backend UI issue, and then hit enter. So now we've what? Staged these files that needs to be pushed to the remote server. Okay. Now let's push this file. Get push origin, and then the origin is what? Hotfix. Okay. Oh, hotfix. Enter. So now the issue we resolve has been pushed to what? Hotfix. Let's go to the repository and then reload the page and then go to what? Branches. So as you can see, we have our new branch here, which is the hotfix branch. When you open it, you see the issues we fix. And then the same thing. Now let's commit this into the, so this issue that we fix, okay, it doesn't apply to either the feature branch or the main branch. So as you can see, we just have what is the first what content that we added, and that's the same thing for the backend as well in the feature branch. And also in the main branch, these changes in the hotfix branch is not here present. Okay, currently the main branch and then the feature branch has the same what, they have the same code base. Okay, except the hotfix branch that has what changes made and fixes what's made. So now let's push these changes to, let's merge these changes into the feature branch. Okay, so we are going to first of all check out of the hotfix branch. So let's do git checkout. The branch name is what? Feature. So we have now what? Check out the what into the feature branch. And then let's merge. Git merge hotfix. Then enter. So it says what? These changes. So you see changes that needs to be what? Committed to the feature branch. Let's do git push. And then origin feature, and then hit enter. So all the changes on the hotfix has been pushed to the feature branch. So when you go to the repository and then you reload the page and then go to the feature branch right now, you see that those changes has been what? Pushed to the, so this is how it works. Okay, so that's the Git workflow and how Git and GitHub works. So how do we manage merge conflicts? Okay, like I said, merge conflicts is it basically happens when changes, or it occurs when changes in a different branch affects the same lines of code. So Git will basically notify you. So now that we have 3 branches, if there are changes in the feature branch that is slightly different from the changes in the hotfix branch or even the main branch, and I try to move those changes to, it will tell me that there's a conflict, so I need to probably resolve it before. Okay. So let's see. Because of the length of the video, we cannot create that. But I mean, that's basically how. Um, so how do you resolve the conflict? So you resolve the conflict by ensuring that uh, you manually edit the file to resolve the conflict. And that's you choose which changes you want to what accept and which changes you want to what remove. And this will remove the changes that what you don't want. Okay. This will remove the changes that you don't want. So it's just as simple as that. And some Git commands, okay, that's important Git commands that you need to keep as a DevOps engineer. You need to do like Git status. So Git status probably check the status of your working directory. And when I say working, these are working directory, which is what GitHub. Okay. So let's try this command. Let's clear and then Git status. So you can see our branch is clean and there is nothing. The feature branch is go. We've already committed all the changes to the remote. And you also do git log. So you can see it as what? Give us all the log of our work since we started the demo. So you can see the history or the details. So you can see the author and date that the changes were made, the head, I spoke about the head earlier, the feature branch, so it gives you all the, and this is the hash that I was talking about. So every time you make a comment, there is a hash that is being created and get to use that to track your changes. And you can be able to revert using this hash key. So every single thing that we've done, it is giving us like a step-by-step guide of what we've done. So initially we did the initial comment, then we created a UI folder, and then next we added TypeScript comments in backend and then in the frontend.cs and what have you. So there's another command which we call the diff git. So git diff actually shows you changes between your comments. It gives you changes between your git remote, so you kind of list the remote repositories associated with your local branch. So we can do this. So let's open a new terminal and let's do git remote dash v. So you can see we have what the remote repository that is associated with our local repository. So we have fetch and then what push. All right, and there are quite a number of them. We have git pull, git research, git. So if we have different developers that is working on this project, every time I'm going to work on this project, I need to pull the changes that the previous developer has committed or has pushed to the remote server. So you can use git pull, git reset. So git reset will undo the changes in the working directory or the staging area. We have git stash, which will temporarily save changes that are not ready to be committed. So you can save all these changes if you don't want to commit them, but you want to finish other dependencies before you push that code to the remote. So you can use git stash to be able to stash them. And then finally you can use git create. So git tag. Okay, so git tag helps you to create tags to mark specific point in history as important. So you can use like release and all of that. So yeah, that's about Git. I believe you've learned a lot. I will push the notes in the repository so that you can have access to it, and then hopefully you continue to learn and understand what Git is. So you need to practice, 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 practice. So watch the videos, subscribe to the channel if you haven't, and let's create impact together. So I have a couple of videos on the channel that you can go ahead and then go and watch if you haven't watched it yet. So this is the channel if you haven't watched our previous videos. So we had a live stream videos on Linux part 1 and part 2. We also had a session on how to write Python automation script. So go and watch those videos and continue learning. This latest video is also posted on the channel. So subscribe to the channel. Let's hit 1K subscriptions. Watch the videos, and let's grow the channel together. Alright, so if you have any questions, you can comment in the comment section of the video, and I'll do well to answer all your questions. Thank you, and kindly subscribe to the channel, watch the video, and this year is a new year. Make it a point to learn DevOps, and don't just learn DevOps, but become great at it. Okay, thank you guys. Bye bye.